Hi everyone. So today I'm doing this daily lead code challenge question, and this was a question about 3 or 4 days ago, and I had skipped this question, so I'm trying this today. Let's see. 106. Construct binary tree from in-order and post-order traversal. So the question is, I'm not this question before. Okay. Given two integer arrays in-order and post-order, where in-order is the in given two integer arrays in order and post order, where in order is the in order traversal of a binary tree and post order is the post order traversal of the same tree. Construct and return the binary tree. Okay, so we'll be given in order and post order, and we need to return the binary tree. And example 2 also the same, and the constraints in order length. So it means that there will be at least one node and there will be at most 3000 nodes, and the value can be negative, positive or 0. They all consist of unique values, so there will not be duplicate values, and each value of post order also appears in order, obviously, because it is the same tree. And in order is guaranteed to be the, so it means that there is no any invalid cases. Okay, um so let's see. For this example, if I'm given the in order traversal, then how can I build a tree? So if this is 9, then if this is in order means left root and right, and post order means left, right and root. Left means left subtree, root and then right subtree. But in post order, first of all, left subtree, right subtree and then root. So if we are just looking at this in order array, then yeah, before looking at this question, I'll just draw in order and post order of a random tree. So for example, suppose if I'm given A, B, C, D, E, or F, suppose, then what is the in order of this one? So first of all, in order means left, root and right? So first of all, I'm starting from E, but first of all, before I write A, I need to write its left subtree before. So I look at A's left subtree first. Okay, A's left subtree, I look at it now. In A's left subtree there is B, D, E, and before writing B, I need to, before looking at B, I need to look at its B's left subtree. So let's look at B's left subtree, and B's left subtree has just D only, and D's left and right is null. So I can just write, so D's left and right is null, right? Here it is null, so it means it is a leaf node. So instead of writing null, so it is like, if I was just given a D as a tree, then how would I write it? Instead I will not write null D null, right? I'll just write D. So what would happen is, so first of all, left is D, and then I'll go to its root. After left subtree is finished, I'll go to the root, and after B's root is finished, then I'll write B's right subtree, that is E, and after this is finished, I'll go to this B, to this left subtree's root, that is A. So A's left subtree is done, A is done, and now I look at A's right subtree. So I need to write C first, because C's left is null, C, F. Okay, now A's right subtree is also done. Now I can, yeah, now this is complete. So this is left, root and right subtree, right? For if we consider A as a root, yeah. And if I'm looking at post order, then it would be left left, right, and root, right? So first of all, we will look at its left, that is D, and then we will look at right before looking at root. So E, B. Now we have looked at A's left subtree. Now we look at A's right subtree. Alright, so before looking at A, so what is the right subtree? It is left is null and right F root. So now this is the left sub A's left subtree, A's right subtree, now A. So this is our Inorder and Postorder for this one. So if we are looking at this, so it is easy, right? It is easy to go from a go from a tree to Inorder Postorder. But how can I just look at Inorder Postorder array and then create a tree? Because so combination of Inorder and Postorder will form a unique tree. But if I'm just given an Inorder array and then say, if the question just gave me an Inorder, then I could not form a unique binary tree from this, because this tree can be formed from this Inorder, and different types of tree could be formed, right? Like if I are just given this this data, then I could think like then the tree could look then the tree might look like, so in order left, root, and right. So this might be my left and this might be my root, right? So I can just consider that, okay, D is I can just consider B as root and D as its left subtree and EACF as my right subtree, if this was in order. So it is necessary to find which one is the root. I can consider D as root. So if D was root, then all this would be my right subtree, right? If B is root, then I just drew that before. If E is root, then the DB would be my left subtree and ACF would be my right subtree. So yeah, if I'm just given Inorder's data, then I cannot form an array of form a unique, binary tree. There would be multiple binary trees that I can create. So if I'm given a post order, then I can create a unique binary tree. So I think first of all, from post order I can just see, right? So because in post order it is we can see that first of all we are looking at left subtree, right subtree, and then root. So it means that the root is always at last. So that is easy, right? So A and so this is post orders. So post order would give us the root, because every time post order would give the root. So the last value in a post order is the root always. And if this is a root, then we would know what is it in left and right. So if we are just given post order, not in order, then we would not know what is left and right? We know A is left, but DE might be left and BFC might be right. D might be left, EBFC might be right subtree. So to know which one is left and right, we can just look here. And so okay, DBE, it is a left subtree, and the right subtree has values ACF, right? But we also need to, we just constructed this tree till now we need to do the same for DBE and ACF as well. So we need to find, we know that this tree contains DBE, but what is the root of this tree? I think that we can just check the post order value here to find that. So we just know, I'm not sure about this, so let's look. So A is the now what is left? DEFC is left, right? Because we are done with so it means that it is always like post order always looks at left subtree, right subtree, and root, right? So it means that after we are done with the root, it means that this right subtree's root is C, isn't it? This shows that, right? because we already looked at CA. We already looked at A, so it means, so whatever the value is here, the C can be the right subtree's root. So I can just say that okay, C is right subtree's root. So because this is my in-order value, so when I have this value, then when post order, so this is the initial, right, post order. So the post order changed to DEFC, and in order now we are looking at what was this value, ACF, CF, as in order. We are looking at the right subtree. So the value is C now. The root is C. So we look at A and F now. And now we know that after looking at C, now it's left and right subtree, right? So we know that C is the root, and C is, whatever the root is, its right subtree is this one, right? Because that was the root, and root comes after right subtree. So the value would be, now the root would be F, right? Now the, I can just keep it as F D E, post order is DEFC and ACF. Okay, I'm just updating. Now C is gone, and now we are just looking at F. So F is the in order now. F is the, F is the value that we are looking at now, and F is the array, F is the tree that we are looking at right now, and we can see that okay, F is the root, right? So we can see that F is the root, so F will be the root here, and F will be the root, and we can see that there is no left and right subtree. So left is also empty and right is also empty, right? There is no any values here, because this is just F, or there is just F only. So it means that, what does it mean? Since in order is F now, and post order now we have DEB remaining, and F was the root, and we are trying to find F's right subtree now. So we just removed F right here from here. So if F had its children, if F had its left subtree and right subtree, then it would come here, right? F's right subtree, F's right subtree, and F's left subtree, right? Here, F's F's right subtree, F. So this is the root, and oh, because this is the post order, so it would be like, so if F had left subtree and right subtree, then its right subtree would come before F, right? But since we can see that F does not have any right subtree, so what if F had a right subtree? What if F had just a left subtree? Then what would happen? If F had just a left subtree, then suppose let's say L, then the post order would be, in this case it would be LF, right? LF. So this would be L LF, and even this is LF. C's left is A and C's right is LF, right? So it would be LF here, and F subtree is L. Okay, so when we when we are looking at this tree, when we are looking at, okay, F, there would be LF here in the in order, because we are always looking at the right subtree first, right? So in the post order, first of all, the root is C and we are looking at C. C's left is A and C's right is LF, right? So first of all, we are just looking for the in order of LF. So we are looking at the in order of LF, and okay, so for the in order of LF, there is L, and if the root is L, then what is the case? We can see that if the root is L, oh sorry, not the root is not L, but just a second. Okay, I was just taking a break because this question just made my mind go dizzy. Give post order DV. It's already 5:21, and my friends had said that they would arrive by 5 p.m., but they haven't still arrived, and there's no message. I think they will be here soon, so I will just complete this question fast. Post order DEBL. What should I do? This is DPEALCF. and DEPLFCA. Post order, in order. Is this a medium or harder question? I think it is pretty straightforward. Like, post order would give me the root, and in order would say me what is the left subtree and right subtree. And if I know a tree, then I can find its roots again by looking at post order. So first of all, I would, because post order is left subtree, right subtree, and root, right? So there will always be, because this is also a tree, left tree and right tree and root. So, and this is a tree, right? So all the tree will always have a structure, right? Tree will always have a structure, like it will be have its children, left children, it will have its root, and it will have its right children, right? Left, right, and root. So every tree will have left, right, and tree, and every post order, for post order I'll traverse every tree as left subtree, right subtree, and root. So it will be like, even for left subtree there will be left subtree, right subtree, root, and even for left subtree there will be the same, it is the same case. Even for left subtree also, there will be left subtree, right subtree, and root. So same structure. So it means that in post order post order there will always be, root at last. So after I finish look at root, then I can just look at, that root's right subtree now, and it will give me the root of it, that this root's right subtree, right? If I'm looking at post order. So first of all, post order's last value will give me root, and before root also there will be a root of it, that right subtree, and before that root also there will be root of that right subtree if there is a right subtree. Otherwise, if there is not right subtree at all, then there will be root of left subtree, right? So that is the main concept. Wow, I took like I took about 2 minutes TikTok break, and I feel like um I feel like I figured out this problem more clearly. Okay, so I'll just write what I just discovered. Root, left, right, root. So there will be always root at last in the post order traversal, root of some tree, right? So even if there is so like I can say, right, so 3 is a, okay, I'll just look at C. So A is the root, and after A there is C. So C is also the root of its root of A's left, A's right subtree, and F is root of C's right subtree, and L is root of since F does not have right subtree, so L is root of F's left subtree, and now B is root of A's left subtree, E is root of right's B's right subtree, and D is root of B's left subtree, right? Um, there will be root of, there will be another root of roots. Before that, before that original kind of root, there will be another root of, there will be root of the this original roots right subtree tree if it is present. Otherwise, there will be root of this original original left subtree if it is present, right? So if it is not present at all, so suppose if there is just a only, then there will be just a. So before it there, before a there is nothing. Is this statement correct or not? I think it is, right? If we look at this one, there is left, we are always looking at left subtree first and right subtree and then root. So if we are looking at this tree, then we are always looking at a left subtree, its right subtree and then root. So even um, before root also we are looking at, we will print right subtree, right? So even for this right subtree also, we are looking at C's left subtree and its right subtree and then root. So before any root there will always be root of its C's right subtree, right? So even before L there will be root of L's right subtree, and even before F there will be root of F's right subtree. If not, there will be L. So before C there will be F, and after F is completed, after C's right subtree is completed, then there will be, I'm going backwards, okay? So before C there will be F, and after this is completed, then there will be, we will look at C's left subtree's root will be there. Okay, I think this is fine. And we always know, by looking at Inorder traversal, we would always know, if we are given a root, then we would always know its left and right, what is at left and what is at right. So yeah, if we are by looking at Inorder, if we know what is at C's left and what is at C's right, what are the values at C's left and what are the values at C's right, then we can just, I think, so suppose if we are looking at C, then we know that C's left is empty and C's right as FL, right? So by looking at the post-order traversal, we know that okay, F is the root, and by looking at the in order only, we know that F's right is empty. So we know that L must be the L must be the root of 7's F's left. So yeah, after we finish, so the thing is that we look at the root, and first of all we look at its right subtree, and then after we complete a root's right subtree, then we'll look at the left subtree, because we would only know the root of the right subtrees in the beginning. Okay, because it is like this. So first of all we'll look at root right subtree only, right subtree only. Okay, so it means that I'll just write the, it means that Inorder Postorder, state my messenger because I'm getting message. Inorder Postorder, so Postorder and Inorder, I just want to think about this one. And So it means that we are looking at post order. So what is the post order? Post orders post order that length minus 1. Yeah, what is that value? Then that will be the root, right? So after we get the root, then we would know what is the value, what is the left subtree and right subtree, right? What is the left subtree and the right subtree? So once we get root, then we need to check first, uh, get right subtrees. First of all, we need to construct its right subtree first, right? Because we know the right subtrees. So construct right subtree and root that length, root that right would be equal to construct right subtree, and we'd keep some kind of index range. We would pass right subtree here. So after we are done with right subtree, then we now do left, and we just construct the left subtree now. Right, so I think this is it. So I think we should construct right subtree, construct, or I can just say that construct tree. So this will be a function construct tree, and I will be given an array, or I can say, so post order will always be the same. I think that I need to have the in order array, because in order array would give me exactly the value. So this is my arrays range. Okay, in order arrays range. So this is my start of the in order array, and this is my end of the in order array. So whenever I find the root, then I know that, whenever I find the root, right? So I know that 3 is the root. So I'm just looking here. So if this is the tree, then I know that, okay, I know that a is the root right here, because a is at last. I know that a is at root. So I know that, so I need to pass now right subtrees array to find right, to construct the right subtree, right? So I would just pass this array. It means that I would pass start will be equal to mid plus 1. So I need to find the index of root in order. So what is the index of the root in order? That, so if it is a, then a plus 1. So my left would be plus 1 and end would be the same for constructing right, and for constructing left it would be it would be, start would be the same and end would be minus 1, right? Sorry, end would be in this minus 1. So yeah, so if I need to find this first. Yeah, if I find index of root in order, then this is what it takes, right? I need to do, I need to find this. So suppose if I find this, then I will pass this. Oh, okay, I think that post order that length minus 1, maybe I can pop, right? Because post order that pop poop, oh my god, pop, because I would need to find next root. So that's why after I find a new root, I'll just pop it, and at last I would return a root, because yeah, and I'd first of all call 0 comma in order that length -1, and I'll just return this. Okay, and what else? What else do I need to think about? So root dot right is equal to, are there any base cases? So this will be my root. And what if this is already if, because sometimes sometimes this might be like, suppose if this is the case, if we are at C, suppose we if we are at suppose if we are at F, right, and F's left and right, they will both be null. So F's left will also be null and F's right will also be null. I mean, the index will also show that, right? Because we're just saying so if we are at, what's getting messages, let's reply. So my start and end will be, when I'm at F, then my start and end will be here. So for my F's left, my for my F's left, when I'm looking at left, then so when I'm looking at right, then it will be, start will be here, right? So end will be greater than start. If end is greater than start, that is the same even for, so if it is the beginning, then start will go to the left. If, or what, if I'm going right, then it will be, start will be, oh, start will be greater than end actually. So start will be greater than end in this case. So F is null, and if F does not have any children, then start will be greater than end. So it means that it doesn't have any children, so I will just return null at that point. So root dot left will be null at that point. So if there is just F, then F's left will be null, F's right will be null, and then F will be returned to C, right? And after F will be returned to C, now we will check C's left. Okay, I think this is solid. Start, end, this is fine, this would work. Did I leave anything else? So what I did here is construct tree and 0 in order that length -1, and construct start, and I passed start and end of in order to just to just pass it as a tree, because I need a tree here. And once I get a tree, I know which one is the root from post order. So once I get which one is the root, then I'll just say that roots right. I'd find roots right first, because I can access roots right. I can access root of right subtree first from the post order end. So that is why I'm doing root right. I cannot do root left before root left, root that, like I cannot do this before root that left before root that right, because post order's last value is always root of the right subtree, uh, not the not the root of the left subtree. So only if sometimes only if root of right subtree is null, right? Sometimes root of right subtree might be null, right, like this, then the last value would be root of left subtree. Yeah, so it is like we are doing a recursion. It is kind of DFS. First of all, we are looking at right, right, right. Like I think that I became clear of the solution by drawing this. So first of all, we are just looking at root, and then right subtree is root, and then right, and then right subtree is root, right subtree is root. Only if right subtree is there is no right subtree, then we are looking at left subtree. So first of all, right subtree and then left subtree. After we are done with one tree, then we are looking at another tree. Okay. Okay, I think this is fine. Now I need to think this is also fine. So how to find index of root in order? Uh, so I know that okay, A is the root, but how would I know that is position here? One way is to just traverse it, but if I traverse, then I need to do it with n square times, right? I think that I can just build a map where I can just put the position of all the values and then I can access it, right? So let's build a map is equal to empty, and then for constant for let I is equal to 0, I is less than or I is less than in order in order that length I plus plus and map. So my map will have value in order I and value I. So yeah, I would know the index, right? So I can find from this map of root. So this would give me the index of the root. Will it work? No, it did not work. Through oh okay, I need to build a root tree node. So root is equal to root value new tree node root value, right? So this is my root value root node. If it is a step, okay, it got accepted. Wow. Okay, yeah, I was about to leave this question in the middle, but I just went. I just took a short break and then came back, which really helped me to get a better understanding and to look this question from a fresh perspective. So yeah, I'm glad that I came back. Okay, thank you so much everyone for watching. Bye.